Hi students, in this video I'll be going through the 2023 O-Level Mathematics Paper 1 question 24. Alright, so let's read the question. So the question goes, the intensity I watts per meter square of radiation from the sun is inversely proportional to the square of the distance d million kilometers from the sun. Right, so over here we have an inverse proportional question, okay, whereby the two quantities involved are I, okay, the intensity from the sun, okay, of radiation from the sun, and D, the distance of the particular planet from the sun. All right. So in this case, we can write out the proportion statement. So I is inversely proportional to the square of the distance D, right? Okay, so the equation would be I equals to K over D square. Okay, so where K is a constant. Constant. All right, so let's see what information they have, which will enable us to find K. So the average distance of Mars from the sun is 228 kilometer. So this one is the distance for Mars, okay, for Mars. Okay, then the average distance of Earth from the sun, okay, so this one would be D for Earth, all right, D for Earth. Right, so the intensity of the sun's radiation at Earth is approximately 1370. So this 1370 is the I for Earth, okay, the intensity at Earth. Right, so using this pair of values, okay, 150, D equals to 150, and I equals to 1370, we will then be able to calculate the value of the constant K. Okay, then once we know the value of the constant K, then they give us the distance from Mars, right, D from Mars, then we will be able to use it to calculate the intensity of the sun's radiation at Mars, okay, which is what they want us to do, right? Okay, so let's put in the pair of values, okay, to find K. So when D equals to, okay, when D equals to 150, right, I equals to 1370. Okay, so let's plug this pair of values inside the equation. So K over 150 square. So K, it will be equals to 1370 times 150 square. Okay, so that will give us 30825,000. Okay, so K rather big value. Okay, so now once we know K, we have fully known the equation already. Okay, so therefore I will be 30825,000 over D square. Right? Okay, so now in order to calculate the intensity of the sun's radiation at Mars, all we need to do is to put in the distance of Mars from the sun, right? So when D equals to 228, so when D equals to 228, I will be equals to 30825,000 over 228 square, right? So that will give us an answer of I equals to 539. Okay, so just like this, we will have solved the question already. Okay, so 539. Okay, so this will be the answer for part A. Okay, then in part B, they ask us to an explanation question. So explain what happens to the intensity of the sun's radiation when the distance from the sun is doubled. Okay, so now they have a general case whereby they say that there's this original distance, okay, with a particular intensity. Okay, now they want to double that distance and ask you what will happen to that original intensity over here. Okay, so over here we need to pay attention to the equation. Okay, so note that in this question they only give you one line to write your answer, so it should be something that is intuitive to you. That means one look at the inverse proportion equation, you should be able to tell what's going to happen to the intensity. Okay, but anyway, let's do some. I'm going to do some working to explain to you what is going to happen to the intensity when the distance is doubled. All right. Okay, so you see, I equals to K over D square, right? So let's say for a particular I naught, okay, original intensity, okay, the distance is D, right? So we have I naught equals to K over D square. Okay, so now they are going to double the distance, right? So the distance is going to be doubled. Okay, so when the distance is doubled, so when D becomes 2D, Okay, so we are going to have a new intensity, right? Okay, so what would this new intensity be in relation to the original intensity I naught? Okay, so K. Okay, so always remember D squared. So when D becomes 2D, we need to square the whole thing. Okay, not just put 2 then D squared. Must put bracket 2D squared. Okay, so if you expand this, 2D squared becomes 4. 2D whole thing squared becomes 4D squared, right? Okay, you should notice that you can actually separate this. Okay, so you see if you agree with me, this will become 1/4 times K over D squared. Okay, but as you can see over here, K over D squared is I naught, right? So this one becomes 1/4 I naught. So what happens when you double the distance? Okay, you see the new intensity, it becomes 1/4 times of the original intensity. Okay, so this is what happens when you double the distance. Okay, for a relationship whereby the intensity is proportional or inversely proportional to the square of the distance. Okay, so when you double the distance, the intensity becomes a quarter. Okay, so so now we can answer this question already. So we can just write the sun's intensity, the intensity of the sun's radiation is 1/4 times the original intensity. Okay, so we can just write a simple statement. In fact, they only just give us one line, so they are not expecting an answer that is very long, right? Okay, so actually this relationship is a rather famous one in physics, okay, in the world of science. Okay, so it's actually called the inverse square law. Okay, so how does the inverse square law work? So it actually works for anything, okay, any form of radiation that radiates out in all directions. Okay, so if any radiation that radiates out in all directions, the intensity of that radiation, right, is going to follow the inverse square law. Okay, so you see over here, let's say the source of strength is at the center over here, right? So the radiation is radiating out uh, in all directions like this. Okay. Okay, so you can see that when the distance is doubled, right? Okay, let's focus on this particular shape over here. Okay, so over here, okay, in relation to this one, all right? Okay, so you can see that based on this shape over here, okay, we have similar figures, okay, we have similar solids. So when the distance is doubled, so the original distance is r, right? Okay, so when this distance is doubled, it becomes 2r. Not only does this distance double, okay, this height over here will also double. Okay, so let's say this is h, right? Okay, so this will become 2h. Okay, not only will the h double, okay, this is the thickness over here, okay, let's call this t, okay, it's also going to double. Okay, so as you can see over here, if the height doubles, the t also doubles. Basically, the area that the radiation spread over, right, is going to be 4 times as big. Okay, originally it's just a, right? Okay, a will be h times t. Okay, but now we have 2h times 2t, so it becomes 4ht. So the area actually becomes 4 times as big. Okay, so now the same radiation, right, from the center, this source, right, is spread over an area that is 4 times as big. So if it's spread over an area that is 4 times as big, the intensity is going to be 4 times smaller, okay, because you have the same radiation spreading over an area that is 4 times bigger. Okay, and that's why when you double the distance, okay, when you double the distance, the intensity becomes a quarter. Okay, then if you can see from here, what happens if you triple the distance? Okay, triple a distance, then the intensity will become I, okay, nu, right, equals to K over triple the distance square. Okay, then it's going to become 9d squared, okay, which will become 1 over 9 of the original intensity. Okay, so it becomes 9 times bigger, right? The 9 times lesser the intensity. Okay, so this is called actually a famous thing called the inverse square law, and it actually applies to a lot of things. Okay, so let me just bring you to another website, okay, to take a look. Okay, so in the inverse square law, okay, as you can see here, uh, any point source which spreads its influence equally in all directions without limit will obey the inverse square law. Right? So this actually applies to a lot of things. Okay, for example, gravity. Okay, if you are 2 times further away from the source, then the intensity of gravity is going to become a quarter times, okay, the original intensity. Okay, electric field. Okay, if you are 2 times the distance away from an electric charge source, okay, then the strength of the electric field is going to be 1/4 times. Okay, okay, radiation. Okay, as we have done in the question. Okay, so inverse square law is actually a rather famous law in the realm of physics. Okay, it applies to a lot of areas. Okay, so I hope that this sharing has enhanced your understanding, okay, about the question that you have just done.